Welcome to Train Signal. This is the video for Lab 3 of the Wins in Server 2003 Video CBT Lab Series. In this video, we're going to take a look at several different things, including the LMHOST file, and we're just going to kind of revisit this briefly just to make sure that you have a good comfort level with this. We did discuss this also in the Wins Concepts video, also on the CD. From there, we're going to go into the Wins client node types, and these describe the different types of Wins clients that we can have on our network. We're going to look at how we can set these up and configure these using DHCP. From there, we're going to explore disabling NetBIOS, and we'll take a look at disabling NetBIOS manually as well as automatically through DHCP as well. After we finish that out, we'll take a look at how we can work with NetBIOS, what we can and can't do once NetBIOS is disabled. And then lastly, we're going to take a quick look at the replication models between for larger Wins environments. So we'll take a look at the full mesh model as well as the hub and spoke model. Okay, let's get started first by taking a look at our LMHOST file. And recall that an LMHOST file is found on any Windows client, okay, post Windows 95 and later. So if we're going to look for the LMHOST file, what we need to do is look in the system root and then look into a specified directory. So let's go take a look so it's a little bit more visual here. So I'm going to my computer, and this particular installation of Windows XP is on the C drive. So if I open up C, I see that I have the Windows directory. Okay, and then from here we're going down into the System32 directory, then into drivers and etc. Now let's take a look at this path right here. When we see C:\Windows, this is represented a lot of times as a variable called system root. Okay, and the system root variable is just indicating where you've installed Windows on your particular system. Okay, and in our case, we've installed XP in the C drive and in the Windows directory, which is the default. Okay, so System32, drivers, etc., and then here's our LMHOST file, which has no extension. If I right-click this, I can go to Open With, and then we're going to use a text editor, Notepad, to actually view this file. Once this file is opened, if we take a look here, we see that there's a lot of information. This file is actually already populated with information. All of this is instructional, however, and there's actually nothing in this file that's a configuration. Okay, all this information here is telling you how the LMHOST file can be used, what entries you need to place in it, etc., etc. If you go down to the end here, you see there's nothing at the end of this file, and this is actually where you'd start typing information in. Okay, because these pound signs here, these are remark signs, and these are indicating that this line should be remarked out, this line should be remarked out, so on and so forth. So if we wanted to actually put an entry in, we'd have to go down to the bottom here. Now, why would we put an entry in here? Well, the LMHOST file is really not used too much anymore. Okay, and if you're not familiar with the file, this LMHOST file was used before we started using Win servers to give us that NetBIOS name resolution. Okay, and what we'd literally have to do is place this file on each different computer in your network, and then you would put this file, or you'd populate this file with information that included the name of the computer and the IP address, just like we see up here. Okay, so this entry, at least up to this point, is indicating to us that this IP address belongs to a computer named Rhino. Okay, so by putting this entry into your LMHOST file, this would allow you to actually connect over to this computer by using the computer name Rhino and not having to memorize the IP address. So if we were going to use this computer on our network, we'd have to put an entry in here that included the IP address of one of our computers. Okay, and then after this, you have to put at least one space. I just tabbed over, and then you have to put the name of the computer itself. Okay, server 1. All right, so that's an entry here in our LMHOST file. I can hit enter here and go on and now add another entry. Okay, and there's server 2. Now these are some basic entries, and this will accomplish the name resolution task that we were speaking of before. Okay, and this you really won't have to use on a regular basis, but for troubleshooting purposes, I have read situations before where networks aren't able to connect to, let's say, a domain controller or some sort of other network resource, and the LMHOST file has been used to actually give this computer connectivity over to that network resource that it's trying to connect to. So this is something that you want to have in your bag of tricks, per se, so at any point you can actually use this LMHOST file to get the job done. Right now, however, we're not going to use this file. We just wanted to demonstrate this briefly, give you a feel for how it works. So we can exit out of this file, and I'm going to do so without saving anything, I want to make sure that there are no changes here that affect some of the other things that we're going to be looking at later on in this lab. Okay, the next piece we'll look at then are the WINS client node types. And we have 4 different WINS client node types: B node, P node, M node, and H node. This should be node, not mode. Okay, B node stands for broadcast mode. This was how NetBIOS clients were initially set up, and B node indicates that this machine is going to broadcast out looking for another computer in the network. Okay, so if we were just operating as a B node WINS client, this machine wouldn't even bother going to the WINS server. It would simply broadcast out, shouting for server 1 or shouting for server 2, and hoping one of those servers would respond with its IP address. Okay, if they're on the other side of a router, okay, or in a remote network, also on the other side of a router, those machines just would not be able to respond because there's no way that that broadcast is going to get through that router over to the destination subnet. P node, okay, is used with NetBIOS name servers. Okay, NetBIOS name servers. So what we're indicating here, if this was a P node client, what we're saying is this machine's configured to use a NetBIOS name server like a WINS server. It's not going to use B node. Okay, so far with B node we have broadcast only, and that's it. With P node we have use a NetBIOS name server like a WINS server, and that's it, nothing else. Okay, so if either one of those fails, then the WINS client would be stuck right there, wouldn't be able to do anything else. Okay, and this is pretty much how we've talked about already. A WINS client just goes out, connects over to that WINS server, and then either registers or pulls information from the WINS server depending upon what type of information it's looking for. Our next node type is M node. Okay, and M node stands for mixed node. With mixed node, what happens is first the WINS client is going to broadcast out on the network. Okay, and after it broadcasts, then it's going to actually use the P node resolution, and it's going to go out to a WINS server. So let's take a look over at a diagram that we had previously. And just to give you a feel for what's going on here, just briefly, we've got a WINS client, connects over to a WINS server, or it can broadcast out here on the network. Okay, so with mixed node, what it's indicating is first we're going to broadcast out. So we broadcast, and we're looking for server 2. Well, in this case, server 2 is available, so it responds back with its IP address, so it's not necessary for this machine to go out and talk to a WINS server. Okay, well, if we had a different situation, maybe we have a routed network like this, okay, and there's another server down here. Well, in this case, when we broadcast, the router's going to stop this from going out. This is a router, by the way. Okay, the router's going to stop this broadcast from passing through, so this machine is eventually not going to be able to get to this server 3 machine down here. In that case, it's then going to go out, contact the WINS server, okay, and then the WINS server should be able to give us the IP address for this machine. Okay, so in a nutshell, broadcast first, then go to the name server. Now, this may not make too much sense to you because you're asking, why would you broadcast first and then go to a name server? Aren't you consuming network resources? And in that case, what's the point? I mean, we're trying to eliminate broadcast. Well, the way this is really helpful is if, let's say you're in a remote situation here where you had a remote site. We're going to draw one out this way, I think. So we have a router out here, and this crosses a wide area network. Okay, maybe we got some remote site out here in, who knows, Arizona someplace. So we have a client computer here. And there's just a small little network here. There's some servers and some other stuff over here. Well, if this machine did not have a WINS server local here, what it'd have to do every time it wanted to connect to the WINS server is go across this routed network over our wide area network here, into the router, into here, talk to the WINS server, and then back again before it could get that IP address. So this could consume network bandwidth that you don't necessarily have to use. Think about if the majority of the resources for this machine were right here local, here in Arizona for this machine. It could just broadcast out, okay, and then it's going to get the name and IP address of any machine that's here local. So in some cases, broadcasting first before you actually go out to the WINS server makes a heck of a lot of sense, okay, and that's what we're talking about here. Okay, our last one is H node, okay, H node, hybrid node. And with hybrid node, we're dealing with our P node first, and then we go to broadcasting. Okay, P node first, then broadcast. So what that means is this machine's going to first, this Wins client is first going to go out to a Wins server. If that doesn't work, then it's going to resort to broadcasting. Now this, a lot of times isn't going to work, but it can under special circumstances. Let's go back over here to our diagram and we'll take a look at how this might work. Okay, so remember, hybrid node, Wins server first, then we're actually going to start broadcasting out. If we are in a situation, let's say that we had a different situation, so this isn't necessarily a wide area network anymore. What if our Wins server is over here, okay, on a remote subnet, and this machine's configured with hybrid mode? So first it goes over here, connects up to the Wins server, but the Wins server doesn't have an entry for one of our servers. Okay, maybe for some reason server 2 is just not in this Wins database. So what will happen then here is the XP1 machine will go out to the Wins server. Server 2's not in the database, but we still need to talk to server 2. So what will happen is we'll broadcast out, okay, and server 2 will hear that broadcast and respond back with its IP address. Okay, so in a situation like this, we're conserving bandwidth initially, and it's resulting in a little bit slower reaction time to get server 2's actual IP address. Okay, so different nodes that we can use. The default that we use in Microsoft Networks is HNode, and without you thinking twice about it, HNode is configured on probably all of your Wins clients. Okay, but you do have this capability of changing this if you're running into performance issues. Okay, then next we have, actually, let's go out and configure this. Let's show you how you would configure this. And we're going to do it through DHCP, and we actually have DHCP set up on server 2. Okay, so we're forming a remote desktop connection over to server 2. Okay, and we're going to just close this Wins database here. We don't need to see this right now. Okay, so this is really only possible, at least in an automated fashion, through DHCP. If you're trying to do this and you don't have a DHCP server, or you're using some other sort of DHCP server, you're probably going to have to manually adjust an entry on each different Wins client machine, and that's probably just not worth it. So what we can do in DHCP, though, and most networks will have DHCP enabled, you can come over here and we can just modify our scope options. Okay, so we're going to be working with this first scope here, and this was already set up previously. So we did this in a different Megalab 5, and we just left this over. But setting up a scope is pretty straightforward. This particular scope option for the Wins node types is not part of the creating a scope wizard. So you're going to have to go through after the fact and add these entries in manually yourself. Okay, well, one of the things that happens when we automatically do this is we get a Wins NBT node type. Okay, Wins/NetBIOS over TCP/IP node type. Okay, and we see over here it's 0 by 8. Okay, it doesn't really mean too much to us. Well, if we open this up and then go to the actual entry here and notice that it's 046, this is the entry we're referring to. Okay, when we go here and then go out to the right under description, it tells us 0, I'm going to move up here so we can see better, 0x1 equals B node, 0x2 equals P node, 0x4 equals M node, 0x8 equals H node. So you have the ability to change this right here if you wanted to. Okay, so just to give you an example, let's say that we had that remote subnet situation where we're wasting bandwidth by always going across the wide area network to talk to that Wins server, and we want to use M node. Okay, we can just go here, do a 0x4 indicating that we want to use M node. Broadcast first, Wins server second. Click OK, and that's really all that there is to it. You see the value has changed here. If we go back over to our XP machine, actually this is not enabled, I don't believe. Let's see here. Maybe it is actually enabled. Okay, let's go back over to our XP machine. What we'll try to do is we're going to enable this machine as a DHCP client and see if it just picks up on this. And this will be good because we need to do this for NetBIOS disabling anyway. So we're going to set this machine up as a DHCP client by choosing Obtain an IP address automatically and then clicking OK a couple times. Now what should happen if this DHCP server is indeed up running on the network, okay, it tells us right here acquiring network address. Let's see if it changes automatically for us. Okay, still says acquiring. Well, I believe that it has it at this point right now. So I'm going to come up here type in ipconfig, and we see that it did pick up an IP address. Okay, now I'm going to run ipconfig all for even more detailed information. Okay, and if we look right now, let's take a look here and see if we find anything else. Okay, host name xp1, primary DNS suffix, great. Node type, mixed. Okay, this is what we were talking about before. Node type is mixed. We picked this setting up from the DHCP client. Okay, so kind of interesting there. All right, now if we go back here again, let's just change it just to test this out. I want to make sure that this is actually working. Maybe you don't believe me and you thought that, you know, the node type was already set at mixed mode. So I'm going to put in a 0x8 here. Click OK. And we're going to come back out here again. And this time, I'm just going to do a release. Okay, and then we'll do a renew right after that to renew our IP address. Okay, so we renewed, we picked up an IP address once again. If we run our ipconfig all command, now let's check out our node type and we see that it's now hybrid. Okay, so just by making that change, we can affect how the DHCP client picks this up. Okay, another thing to look at here, notice that the WINS proxy is enabled by default. We talked about this in our last lab, but the WINS proxy service is actually enabled automatically on these WINS clients without you doing anything here. So we didn't even need to change that in XP. Okay, I'm going to close this. And next thing we're going to take a look at is disabling NetBIOS. Okay, disabling NetBIOS. Now, we talked about this a little bit in the concepts video, but why would we want to disable NetBIOS first? Okay, well, in 2000 and 2003, NetBIOS is no longer required. Okay, NetBIOS is the old way of setting up an application program interface. It's the old way of networking, essentially. Now, we support NetBIOS in both 2000 and 2003, so we maintain backwards compatibility with older legacy operating systems like NT4, Windows 98, Millennium, okay, anything prior to Windows 2000. And we still need to maintain our NetBIOS on our networks until we are absolutely 100% positive that we no longer need to support it. Okay, so once you have 2000 or later on every single system, and, okay, it's a big and, you don't have any NetBIOS applications, they're no longer there. Okay, and NetBIOS applications, these are programs that are written to work using NetBIOS names. And may surprise you, but even Microsoft has some Exchange server and some of their clustering services use NetBIOS names. So even though you're running these, you may still have to, or if you're running these, you may still have to retain NetBIOS on your network. Okay. Now, what's the advantage? Why do we want to disable NetBIOS? Why do we even care? Well, a couple things. Number one, NetBIOS, we have two APIs that we're supporting. Okay, with two APIs, we have twice the security risk, and it also slows down your network. Okay, once you've disabled NetBIOS, you should notice a decent size speed increase because you're no longer dealing with NetBIOS name broadcast anymore. Okay, as you're going to see here in a second, once we've disabled NetBIOS, broadcasting no longer happens in the network. We no longer need to worry about these NetBIOS broadcasts. Okay, so it's going to increase your network speed. So there is incentive to disable NetBIOS. Okay, let's go take a look at how we can do this. On the client side or on even the server side, if you want to do this on a manual basis, all that you have to do is just go to the network card itself, Properties, TCP/IP, go to the Advanced Properties, and then go to the WINS tab. Okay, and from the WINS tab, you see right here NetBIOS setting. Okay, default. Use NetBIOS setting from the DHCP server. If static IP address is used or the DHCP server does not provide NetBIOS setting, and it does not by default, then enable it. Okay, so in essence, we're saying the default setting is to enable NetBIOS over TCP/IP. If you choose this, this is a more specific setting than you get over here. So this is going to ensure that NetBIOS is enabled on your machine, even if the DHCP server tells us otherwise. And then disable NetBIOS over TCP/IP. Same thing. If we choose this option, it will be disabled on this computer. Okay, no ifs, ands, or buts about it. So if I click disable here and click OK, let's see what happens. Okay, so far, nothing's blown up on this computer. Everything seems to be working okay. If I go to start run, type in ipconfig all, okay, and look here, Doesn't really tell me too much here. Oh, except for this right here. NetBIOS over TCP/IP is disabled. Okay, well, big deal. What's that mean to me? Well, when NetBIOS over TCP/IP is disabled, things like My Network Places, okay, are no longer going to work. Okay, so I'm trying to get out there and I want to view all the Windows networks out here. There's nothing there. Okay, this broadcasting's been cut off. Just a second ago, I should have showed you, but we're able to actually see the different network computers that are out there. Or if I try using a NetBIOS name from the run command, okay, not IP addresses, those will still work. But if we try using something like server 1, okay, we're able to connect only because we have DNS names. But if we had another NetBIOS name, if this machine were not part of the domain and this wasn't supplied automatically, we wouldn't be able to connect over to server 1. Okay, you see here it says connect to server1.wbc.local. That's because our primary DNS suffix is configured on this machine as wbc.local, and we're just plugging that in along with server 1. Okay, so it's kind of, I guess, cheating in a way here, allowing us to connect over. But NetBIOS support's just not going to be there. Now, if we go back and we enable it, let's test out and see if we actually get our My Network Places functioning again. Okay, so we put it back to the exact same setting, click OK. Give it a little bit of time. Don't go over there immediately because it takes some time to kind of restart that service, get running again, and keep in mind that this is just going out over the network and it's broadcasting. So sometimes on larger networks, you will not see the entire network right away. Okay, and look what happens all of a sudden. These 3 different work groups or domains show up, and when I open this up, now I see the different machines that are actually out there and part of the network. Okay, so no more My Network Places once you have set up our disabled NetBIOS. Okay, that's the manual way of doing it. Let's take a look at what we can do on a DHCP server, how we can disable this as well. Well, if we go to Scope Options and then go to Configure Options, we can pour through here and look and look and look and look and look, but it's not in here. Okay, I'm looking. Here's WINS, NetBIOS name servers. That's just setting the actual NetBIOS name server. It's not going to help us out with what we're looking for. NetBIOS over TCP/IP priority. What the heck is that? Okay, well, that's a boot P setting, something we don't need to mess with. Okay, so we'll leave that alone. It's not in here, and that's because we need to go to this Advanced tab here. Okay, on this Advanced tab, there are some other things here that we can configure as well. We're not going to go into this. This is covered in our concepts video on the same CD, or I'm sorry, on the DHCP CD, so you may want to look at that. But what we can do from here is we can go into Microsoft Windows 2000 options. Okay, and one of our options here is to Microsoft Disable NetBIOS option. Okay, so if I choose this option and then look over to the right, it says option for enabling or disabling NetBIOS for Windows 2000 clients. Okay, and the setting that I have here is 0x1 actually disables NetBIOS. So when I click OK now and then look here, notice that it puts this entry in here. Okay, it's automatically included as one of the scope options at this point right now. If I go back over to my client machine again, okay, we're in the middle of a lease, so keep in mind we're going to have to release this lease and then renew the lease. Okay, so now I renew the lease, get my IP address back here again. It's hard to type and talk at the same time. Okay, ipconfig all. Okay, and I look down here and notice what we have. We do not have NetBIOS disabled. Okay, why is that? Okay, well, if we go back here and take a look once again, we'll see that the default value they gave us is actually not to disable NetBIOS, but to leave it enabled. Doesn't make a lot of sense, but that's the default option that they gave us here. Okay, so if we go back up there, we're looking up these other settings here. Nowhere in here does it tell us that NetBIOS is disabled. And if the entry is not present, you can assume that then it's not going to be on or functioning. So let's go back over to server 2 here real quick. Take a look at this. Let's try out the option if we put in 0x2, okay? Because this actually is the entry we need to put in here. So Kind of funny, but when you check this, you would think that they give you the default entry as disabling NetBIOS, and it's not the case. You actually have to change this to 0x2, and this entry will indeed disable NetBIOS. Okay, so now we have this value changed. If we go back over here again to our machine, XP1 machine, we're going to release, and then we're going to renew our IP address here next. So we'll give this a second here. Okay, and we see that it did renew. Okay, and now this entry's back again. NetBIOS over TCP/IP shows up as disabled. Okay, and the same thing is going to occur. If we go out here right now and attempt to use My Network Places, we're going to see that all of a sudden it doesn't work again. It's been disabled. Nothing is even here. Okay, so it's a good security thing. Also speeds up your network. So disabling NetBIOS once you can, and it's not going to affect any of the applications or computers in your network, is a good thing. Okay, last we're going to finish this off with replication models. Okay, replication models. Now, we talked in Lab 2 about replication between two different Win servers, replication partners. And I think for the most part, if you're working with a smaller network or you have just a couple, 2 or 3 different Win servers, you can definitely get away with a push-pull model where replication takes place between all the different Win servers, and you don't really need to worry about it too much. In larger Wins networks, though, replication is a problem because database corruption can occur. And this is really a big problem in larger networks where they may have Win servers across the globe. A couple different things, couple different ways we can replicate or set up replication. One is called a mesh design. Okay, and here's an example of this pulled from the lab book, your PDF file on disk 1. Okay, and if you take a look at this, a little bit difficult to read because it's small. But in this situation here, we have 4 different Win servers, and you can just picture these in the 4 different corners of the country, north, south, east, and west. You have Win's clients in each of these offices, okay? Every Win server must replicate with every other Win server in order to keep their Win's databases up to date. So think about this. This Win's client registers here. This Win's client registers here, so on and so forth. Each of these different Win's clients register with their Win server. That all works great, but when it comes time for, let's say, this machine to find a resource over here in this north network, that resource is not going to be contained within its Win server, and that's why replication has to take place. When we're dealing with a full mesh environment like we see here, this Win server is actually replicating with 1, 2, 3 different servers, and replication is traveling in 2 directions with each one. So in essence, we have 6 different replication paths that are set up. In this situation, 4 servers, corruption may not occur, okay, because we don't have that many, but we're definitely running into a risk, and we may not want to set up our Win's replication in a situation like this. A better way of setting up Win's replication is using a hub and spoke model like we see right here, hub and spoke model. Okay, so we can do that exact same example we had before. We have our north, east, south, and west office, just as we talked about. Win's clients will be registering in each one of these offices. Okay, so, we have 4 different networks in essence. Now, though, what's going to happen? Each one of these Win servers is only going to talk to this one central Win server. And it doesn't really matter where the central Win server is located for our example, but there's just this one Win server that's replicating with. Okay, and then this Win server is set up as a push-pull partner. So what's going to happen? Let's just go through the day in a life of a Win's registration and also a Win's name NetBIOS request. A Win's client is first going to register with its Win server. That's going to occur down here. Eventually, that information is going to be replicated over to the hub, the middle server here. Okay? After a while, each one of these machines are going to be replicating back and forth, back and forth, back and forth. So after the course of time, this information that was initially here on this Win server is replicated to this hub, and then it's replicated out to each of the spokes in this topology. Same thing's going to happen on each of these different Win servers. Okay, so the Win's client registers with the Win server replicates to the hub, and the hub then replicates out to each of the different spokes in this environment. Okay, so this is a more efficient model. It really only involves one extra server running Wins, and for an enterprise, that has this many locations, it's probably not a big deal. You could even throw this on an older server, something that doesn't need as much, doesn't require as much, or doesn't have as much resources, less CPU, less memory, etc. Okay, this is going to wrap up Lab 3 then, and also concludes our Wins Video CBT Lab for Windows Server 2003. Thanks for choosing Train Signal. Hope to see you back here real soon.